In this section, we will now look at the third macromolecule, or the second, you can call it depending on how you're listening to them, and these are called as the lipids. Lipids are present abundantly in cell walls or cell membranes. You can see over here, this a cell membrane is composed of a layer of these large bulky molecule. Each of these is one unit of lipid. So you can see a ball and a tail are individual units that are either linked together. Notice the way the heads are all towards the either the inside or the outside, and the tails are meeting each other, and we'll talk about this. So present in the plasma membrane. What are lipids? Lipids are the high energy source. Recall, carbohydrates only give us about 4 kilocalories. Lipids give you 9 kilocalories. So definitely, for example, seals or penguins, which have very heavy coating and they're present in cold climates, will have a lot of lipids stored in their skin. This large creature has a lot of lipids stored on his skin too, to keep him shielded and insulated from the environment. Lipids are also long chains of carbon and hydrogen. As a matter of fact, they are much longer than the carbohydrates. Carbohydrates could be present as singly and in chains. Lipids are always present in chains. Lipids are highly hydrophobic, which means they do not dissolve in water. They repel water, and there are several types of lipids, and we will explore just a few in this section. There are triglycerides, phospholipids, waxes, and steroids. So let's go and look at the first one, which are, what are triglycerides? The common name for triglycerides are fats and oils. So when we say fats, I'm talking about solid fat that can stay at the room temperature. For example, Crisco or butter or margarine, these would be all, or lard, this would be fat. Oils would be vegetable oil, canola oil, or olive oil. These would be all your liquid triglyceride. Both the triglycerides, whether they're fats and oils, they're composed of two units. The first unit is called as the glycerol, which is I'm showing them over here, and they're linked up to 3 fatty acids. So altogether, when they now again combine with the dehydration reaction, again noticed that you have the same thing. You've got the oxygen and the hydrogen forming water and being released out. So each of these is going to be released out as the water molecule. So there are 3 of these. Notice there are 3 water molecules, and the bond that is created by this linkage over here is a new connection, and this is called as the ester bond. And the ester bond links the glycerol to the fatty acid together, and together this entire big complex molecule is either a fat or an oil. So you can see that fat molecules are pretty humongous. Now let's look at some more variations within your fats. Some of these fats are called as saturated fats, and some are unsaturated. So for saturated, we mean by the carbon-hydrogen ratio. I'm trying to change my color. The carbon-hydrogen ratio is maximum, and unsaturated will have fewer hydrogens. Why will they have fewer hydrogens? Is because whenever you have a double bond, as shown over here in these, you will have less hydrogens. Saturated fat will have complete number of hydrogen attached to the carbons. Now example of the unsaturated are your oil, and these are your saturated. And this is your unsaturated. Now notice the image that is shown over here. In an unsaturated, when you have these double bonds, these leaves these open spaces that are called as kinks. On the other hand, in the saturated fat, notice how they're stacked on top of each other. And that's the reason when you have saturated fat in your arteries, they can clog your arteries because they form a barrier around the cell membrane. Another kind of fats that we hear a lot about these days is the term trans fat. Trans fats are as bad as saturated fat because they're partially hydrogenated fat, and when you treat unsaturated fat in this particular manner, they result in trans fat. And the trans fats that you might be familiar of are is the margarine, for example, is a trans fat, and it's equally as bad as a saturated fat. What are phospholipids? Phospholipids are examples of fats or lipids that are present mainly in the cell membrane. So they're present mainly in the cell membrane, and they're similar to triglycerides. They also contain glycerol. They also have a phosphate group, but instead of 3 fatty acids, they have 2 fatty acids. So the third fatty acid has been replaced by this phosphate group. In the triglycerides, we had 3 fatty acids. Now these are present in the plasma membrane, and they have a slight hydrophilic nature to it. So the hydrophilic means that they are water loving, especially the phosphate end. So the reason for having phospholipids in the plasma membrane is to help transport substances from in and out of the cell. Another form of lipid are waxes, and waxes are present usually on the surface of skin or nails or cuticles or insects. So they're usually coated on the outside, and usually fruits and leaves will also have coatings of wax, and they pretty much decrease the water loss by these cells. Waxes are also made up of an alcohol and fatty acid. However, the difference is a wax is usually one long chain instead of a 3 long chain that we were looking at the previous images. Waxes are definitely solid at room temperature. And now the last kind of lipid that is present in living cells are called as the steroids. Steroids are a whole class of lipids that have this unique ring. Notice this is 1 ring, 2 ring, 3 ring, 3 6-sided shape, and the 4th ring is the 5th shape. Whether it's the hormone estrogen, whether it's cholesterol, or whether it's testosterone, all of these they fall into the category of steroids because they have the 4-ring steroid nucleus. The steroid nucleus is a term that is a generic term that if I was to circle this, let's say, let me get the highlighter out. Each of these together will form a steroid nucleus. So that is the basis for all of these groups. And many sex hormones have steroids in them, and cholesterol is the base molecule that also has steroid nucleus. So this concludes all the lipids that we will see in living organisms. Now, here comes the proteins.